Hello everyone. In this video we're going to be solving a radical equation. We have square root of 1 plus square root of x equals x minus 1, and we're going to be solving for x values in two different ways. And I'm pretty sure there's other ways to do it, but I'll be presenting two methods, and we're going to be looking for real solutions mainly, but we can also talk about complex solutions in the comment section down below. So first method first. I'm going to go ahead and do what is normally done to radical equations, squaring both sides and getting rid of all the radicals. This equation is not that bad, even though it looks like it's going to turn into a quartic equation. The result is actually pretty surprising. So start by squaring both sides, because we want to get rid of the outer radical. 1 plus square root of x equals x squared minus 2x plus 1, which is x minus 1 quantity squared. Obviously, 1 cancels right away, which is a good thing, right? That's what makes this problem a little easier. But we still have a radical, so we need to get rid of that as well. So let's go ahead and square both sides one more time. This one without the ones, of course. Square root of x squared is going to be x. And then if you square this term, it's going to be x to the fourth minus 4x cubed. Remember the 2ab. And then plus 4x squared. Let's go ahead and put everything on the same side, and that's going to give us a quartic, but it's actually easier to solve because there's a common factor. You probably saw that already. So I'm going to go ahead and subtract x from both sides. Now, if you try to factor it by grouping, and if you group the first and second terms together, that's not going to help, because what's going to happen is you're going to get stuck. But I think it's also important to see methods that don't work all the time, because it's problem solving isn't like that. Sometimes you try something, it doesn't work, and you have to change it. So like if you take out an x cubed, you get x minus 4, and then if you take out an x, you get 4x minus 1. So the problem is we don't get a common factor, so this is not factorable like that. But we can do it slightly differently by looking at the first and the last terms because of the coefficients, right? Notice that the middle terms both have 4 in them. So let's go ahead and put these together, x to the fourth minus x. And x is a common factor, so I'm going to take out it. X cubed minus 1, and then minus 4x squared is a common factor. That's going to give me x minus 1. Even though we didn't see a common factor, there's going to be 1 because x cubed minus 1 is a difference of 2 cubes, which is factorable, and it contains x minus 1. Let's see how that goes. This is going to be x minus 1, x squared plus x plus 1. Remember the formula, minus 4x squared times x minus 1. We can just factor it completely and then set it equal to 0. We don't have to write the 0 every time. X minus 1 is a common factor, this one and that one. So let's take it out. And then we're going to get x cubed. I'm distributing the x here. Plus x squared plus x minus, what am I going to get from there? 4x squared. And of course, we can kind of combine those like terms. That's going to give us a cubic, but guess what? It's again an easy cubic because x is a common factor. By the way, you could just take the x first out, and then that way you wouldn't have to deal with this, but no big deal, same idea, right? Big difference. So if you take the x out, you're going to get a quadratic, which is very easy to solve, especially with the quadratic formula. So here's my equation with 3 factors. This is going to give me 4 solutions. That's why I told you this is going to become a quartic, right? But here's the problem. Along the way, we squared both sides, right? A couple times. So you have to check your work. That's what happens with radical equations. You introduce sometimes extraneous solutions. Extraneous basically means that they do not satisfy the original equation. They just pop up because of squaring both sides. For example, negative 1 does not equal 1, but if you square both sides, then they're going to be equal. Make sense? That's the idea. Okay. So now here's what we're going to do. We're going to look at every solution, and what we can do is we could have actually paid attention to the domain while we were doing this. For example, at this point, when you have something like 1 plus square root of x, it's supposed to be positive. It is. And since it's a radical, x minus 1 is supposed to be greater than 0. That means x must be greater than 1. Does that make sense? So that's a limitation. And you can keep looking for those, but I'm just going to test it out. So here, let's see what the solutions are. X equals 0, x equals 1. And from here, we're going to get a quadratic equation. Negative b plus minus the square root of b squared minus 4ac, which is 9 minus 4, which is square root of 5 divided by 2. Great. We get two radicals, and actually they're both positive, right? Look at that. So we don't have any negative solutions because that would require square root of x to be well defined, right? But here's one thing. 3 minus root 5 over 2 is actually not greater than 1. Do you know why? Because if 3 minus root 5 over 2 is greater than 1, assume on the contrary, then 3 minus root 5 is going to be greater than 2, and root 5 is going to be less than 1. Obviously, that's not true. Therefore, proof by contradiction, this is not going to happen. All right? So, in other words, we're going to reject the solutions that are less than or equal to 1 because of this requirement. X minus 1 is supposed to be greater than or equal to 0. Before we squared it, remember, that was on the right-hand side. So we're going to reject this one and go with this one. The other ones are so easy to check. Let's go ahead and check them out with the original one. And this will also show, yes, x, anything less than 1 is not going to work. Do you think x equals 0 is going to work? It's not going to work either. The problem is it's not greater than 1. See, that's a good reason. But x equals 1 is going to work. That's actually going to make, wait a minute, x equals 1 is not going to work either. What am I saying? X equals 1 is not greater than 1, is it? Okay, never mind. I don't know what I'm saying. But we only ended up with a single solution, which is weird, right? You solve a quadratic, quartic, but actually it was a radical. Anyways, let's go ahead and take a look at the second method, and then we'll look at something interesting, which is called the graph. Okay, so for my second method, I'm going to go back to the basics. So square root of 1 plus square root of x equals x minus 1. I'm going to add 1 to both sides from the left. I'll tell you why. And then I'll use substitution. This is actually one of those equations where you can kind of set up a system from a single equation, which is cool, right? So I'm going to call this expression the expression inside the radical y. And don't ask why, because you'll see in a little bit. So by this assumption, I'm getting y equals 1 plus square root of x. But this also means that x equals, because the whole thing is x, remember that? 1 plus square root of y, right? So that's our system. You see, why did we turn the single equation into a system? Because this system is very easy to solve because of symmetry. We can go ahead and subtract these equations. And when we subtract, we're going to get y minus x. The one is going to cancel out. We'll get square root of x minus square root of y on the right-hand side. Now, y minus x is normally not factorable, but if you think about radicals, it's factorable over radicals. So we can kind of write it from difference of two squares as this. And then let me write this with a -1 so that I can negate it. Now, you could definitely put everything on the same side, factor, so on and so forth, but I'm going to do things a little differently now. I think it's fun when we try different approaches. First of all, focus on these factors. If x is equal to y or y is equal to x, this is going to work. So that's a solution. Great. Once I know that, I'm going to assume that y doesn't equal x and divide both sides by this to get rid of some of the expressions and simplify my equation. And guess what? This is not possible for real numbers, x and y. Remember, I said that I was going to look for real solutions. By the way, are there any complex solutions to this equation? I don't know. You'll let me know. Okay, so this is not going to work, so we're going to have to reject it, and we ended up with one solution, y equals x or x equals y. But what is y? Y is 1 plus square root of x, and that's supposed to equal x. So this is the equation, the very equation you're supposed to solve. And this can be done in two ways. Let's go ahead and talk about 2a and 2b, or not 2b. Okay, this is 2a, this is 2b. Now with the 2a, I'm going to do the following. I'm going to set square root of x equal to t, and then write this equation as t squared minus t minus 1 equals 0. Obviously, I put everything on this side. And then this is quadratic. Let's go ahead and solve it and then back substitute. This will be by the formula 1 plus minus root 5 over 2, but t is equal to square root of x, so we must square both sides. And that gives us x equals 3 plus minus root 5 over 2 as before, right? The second method, the 2b, is actually we can just isolate x minus 1 and then square both sides. You know how this method works, right? This is going to give you x squared minus 2x plus 1 equals x, or x squared minus 3x plus 1 equals 0. Remember, we've seen this equation before, and if you solve it with the quadratic formula, you're going to get 3 plus minus root 5 over 2 again. So they're going to give you the same thing, but guess what? They're not the solutions because we can only go with the one that is greater than 1. So the single solution to this equation is this one. Yay, that's a winner. Now let's go ahead and take a look at the graph and we'll finish up. All right, here's the graph of x minus 1, which is a line. And the square root of 1 plus square root of x is a very radical function. And they intersect at a single point. As you can see, x must be 3 plus root 5 over 2. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.